Welcome back. Now let us see another topic from Unit 3 in Artificial Intelligence, subject code 22AM301. We are going to have a look on logical agents. In logical agents, we are going to see what is this logic and what is this positional logic and how it's going to work. And what is these knowledge-based agents. So what is a logical agent? We have already seen what are agents and what we talk about agents, which has sensors and actuators. When you're talking about logic agents, so what you're going to talk about is going to think logically. So that is what is going to happen here. An agent can represent knowledge of its world, its goals, and its current situation. So it will be able to estimate the knowledge about the world, what are the different types of goals that can be attained, and the current situation it is being stated. So according to that, when it makes a decision, an agent is called as a logical agent. A logical agent is a collection of sentences. On all those sentences is going to have some logic. So that is what is the purpose of this logical agent. By using this logical sentences, we are going to infer some knowledge. Okay, and those knowledge is going to be inferred and concluded through the desired actions. Okay, these logical statements and the knowledge that has been acquired about the environment is going to fetch some conclusions for us, and those conclusions are going to be in a logical manner. The conclusions are achieved by certain actions or set of actions, just one action or a set of actions is appropriate to achieve the goal. So what is the goal? Whether you can reach the goal with one action or you can reach the goal by a set of actions is how it is going to attain using the logic, right? The knowledge and reasoning are the important to logical agents. The knowledge is important and reasoning why we are taking that kind of decision is important for the logical agent because they enable successful behaviors to achieve a desired goal. So they have made successful decisions accordingly. So when we are talking about logical agents, it's very important to know about what is a knowledge base and who is this knowledge base agent. Okay, knowledge base is nothing but it's going to carry some information or rules, like what kind of concept is going to be there and what kind of action can be taken accordingly. Okay, the central component is kind of a database. Okay, central component of a knowledge base agent is nothing but your knowledge base, which you call technically as KB. The KB contains a set of sentences in the formal language. It has its own language. Okay, formal language. It is called as knowledge base language. Okay, in that using those formal languages, this is kind of a database which keeps information or set of statements which has already been inferred from the environment. Okay, so what is the difference between a knowledge base and a database? A database just contains information about what is going to happen and what is going to be the reflection. But knowledge base, more than a database, it is going to train itself according to the current situation or a new kind of information which is going to keep on updating. But database, once you say to update, then only it will update. But knowledge base is not going to be like that. It will keep on updating. Okay. So knowledge base, these sentences are expressed using a knowledge representation language. That is nothing but your knowledge base language. Using two formal languages, we said, right? So these formal languages using tell and ask in your pseudocode, you will be seeing this. Tell and ask will help you in generating the facts. Okay, so you need to add certain facts or new information to the KB. You can use the word called tell. It is going to be a technical word. And ask is going to give you the answer for the query which is going to be fetched from your KB. That is nothing but your database. Something like a database. Okay, but this will keep on updating, which is more than a database. Okay, can you understand? Yes. What is this knowledge-based agents? Okay, this is nothing but it has an inference instance. It has a knowledge base. Okay, this knowledge base is nothing going to works as a back end for you, and the inference engine is going to work as a front end for you. So right scenario kind of algorithm is going to be used in the front end, which is going to infer certain information from these algorithms. It's going to fetch the answer from the knowledge base, which is going to be domain specific. So there is not going to be 1 KB in one model. Okay, the models that we are going to generate is not going to contain one knowledge base. It's going to have multiple knowledge bases. So from that knowledge base, it is going to acquire the answers for the front-end independent algorithms. Okay, it represents states and actions. It incorporates new percepts. Now, percepts are nothing but current situations according to the environment. Then the updated internal representations of the world. Okay, then it reduces the hidden aspects. See, in a lot of problem statements, you will not be able to find out the hidden aspects. You have to it extracts the hidden aspects as the properties of the world, and it deduces the appropriate action for the hidden aspects. Okay, understood? So this is a small pseudocode for you to understand even more. So the pseudocode, as I told you, there are some formal languages like tell and ask. So this has been used in it. Okay, right. So the KB for the current world situation is going to take an action. It's going to be represented in the form of a function. Okay, the knowledge base is represented as KB, and there is going to be a timer that is going to be a set of values like 1 from 0 to n values. There are going to be a knowledge base statement. So it's going to set a time for it. So how long it will be? If the statement is going to be there, it will give you an answer. If it's not going to be there, it will say no, the answer is not available, right? So it has to add the question. So tell and the parameters that are going to be used as knowledge base, the current situation, the percept contains the current situation as well as the time as the parameter. Then the ask parameter, what it does is ask the query, right? And it gives the answer to the action. And according to that, it's going to fetch it from the knowledge base. The action is going to get, it is going to check one by one from 0 to n value. It's going to check using a timer called t is equal to t plus 1. Okay, this is a simple pseudocode for knowledge-based agent. So it is called as a procedural or a declarative statement. A procedural, it encodes desired behaviors directly as a program code. Procedural is nothing but your program code. And declarative is nothing but it builds up the knowledge-based agent, knowledge base for the agent. What kind of agent you are going to have using tell and ask, it is going to build up that knowledge base. Okay, procedural is nothing but your program. Okay, the very good example that is being given for knowledge-based agent is Wumpus example. Wumpus is nothing but a game. Okay, this game, what it's going to do is it's going to have a 4x4 matrix rooms, 4x4 matrix room. So this is how it is going to be having the number of rooms. Okay, it is considered to be each room is going to be covered by a wall. It is going to have a single agent. Okay, and the adjacent, the Wumpus is hiding somewhere. Wumpus is nothing but the monster is the Wumpus. Okay, somewhere in the cave, and it eats anyone who enters the room. So if the agent is being directly going to the Wumpus, he'll eat it. The Wumpus can be shot by the agent. So the agent is going to be having one arrow which can be shot, which can shoot the Wumpus. Okay. Some rooms contain bottomless pit. So there are certain conditions. See, some rooms contain something called pit. Okay, and the pit adjacent columns will have breeze. So when the agent enters into the next column, like this is 1, 1, right? Room 1, 1. When he goes to 1, 2, if he finds out there is a breeze, he checks that there might be a pit here or it can be here. So to restrict him from falling into the pit, he identifies using the rules such like breeze. In the same way, instead of going directly to the Wumpus, there's something called stench, which is smelly. Okay, when the agent moves to 2, 1 room, there is a smell called stench. Okay, this stench tells you or warns the agent that the Wumpus is somewhere beside. Okay, either the Wumpus is here or the Wumpus is here. So when he takes the direction 90 degrees, he will be careful in not to fall down the pit and not to go into the Wumpus. Okay, this is how the game is being played. Okay, understood? So the agent precise the stench. Here, all the things are given in wording. A stench is the smelly when the Wumpus is beside. Okay, it is only in the adjacent square. It is not in the diagonal square. It is in the other square. The same way breeze is in the adjacent to the pit and it is not in the diagonal. And glitter in something. The aim is to find gold. So this is the glitter. G, glitter. Okay, the aim is to go and fetch that gold. A bump is there, walks into a wall. Okay, it is considered that it is having 4 walls. Okay, you should take care of it. The waffle smell is nothing but the stench smell. Okay, if you step directly to the Wumpus, he will kill you. These are the percepts. So the agent can only go forward. He can turn right. He can turn left 90 degrees. So turn right 90 degrees. He can grab. He can shoot. He can climb. If he steps into the Wumpus, he dies. So these are the conditions. So this is how you frame the PEAS. You would have already learned it in your first unit. What is PEAS? PEAS is nothing but performance, environment, accusator, and sensors. So what is the environment talking about? The squares, which is having the adjacent smelly squares and the breezy squares and the glitter, then shooting of one arrow, then grabbing of the gold, then facing the Wumpus directly, then releasing a drop of the gold. There is no smell where there is safe. Okay, the performance matrix is nothing but it is going to calculate. If you attain the goal, you are going to get 1,000 points. It is set. You are going to have a negative points. If you step -1, okay, if arrow is being used, then it is -10. The accutators, how the actions are going to be made. You can turn left, turn right, then forward, grab, release and shoot. Release the gold and shoot the arrow. Right? Grab the gold. Right? Sensors is going to have breezy smell, glitter is going to shine, and smell is where the stench smell. This is how we are going to predict using the agents. So when you are talking about agents, you are supposed to write the PEAs of each and every scenario, like water jet problem or tic-tac-toe problem. This is how you divide and write the PEAs, right? For the Wumpus world also, you are having a gist of what is going to happen in this Wumpus world. So what are the characterizations of the Wumpus world? The observable, it is partially observable. When it steps to each square, it will identify what is happening in and around. Okay, deterministic, it has only yes or no. Right? Episodic, it doesn't have different levels. Static, static. When you start the game, where the pit is going to stay there. It is not going to move. So that is called static. And the sense, smell, and breeze spells are going to be accordingly. So discrete is after you go to that place, you will find out what is going to happen. So that is why discrete. And there is only one single agent who is going to carry the game entirely. So this is all about Wumpus world. Thank you.